This lesson will go over the tangent lines lesson from the circles unit. Some definitions. Tangent line. Tangent line is a line that intersects a circle at exactly one point. So looking at the diagram that you have on your paper, the tangent lines, and this one has two in particular, but we have a tangent line right here because it's touching the circle at one spot. So this here is a tangent line. And we know that lines go on forever in both directions, so you can kind of think about going the other way too. We also have a tangent line over here. Notice that it's touching the circle in one spot, so this is also a tangent line. Point of tangency is the point where the tangent line and the circle intersect. So we have a point of tangency and a point of tangency, and there is only one because by definition a line intersects a circle at exactly one point, which we call tangent. The circumscribed angle is an angle whose rays are tangent to a circle. So this angle right here that's being formed by these two tangent lines is this example of a circumscribed angle. An angle whose rays are tangent to a circle, and the measurement of this particular angle is 180 degrees minus the central angle. And a central angle is an angle that has its center or its vertex at the center. So if you wanted to find this particular angle, I would take 180 degrees minus, I guess I can call it x, minus however much that is. And we'll see it here in a little bit. There are two key concepts, and they're pretty much saying the same thing but in different orders. It says if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So what I have here is I drew the radius, and there's another radius over here. I think the biggest mistake that students make when they deal with circles is they forget that the radius can be drawn anywhere. The trick is drawing the radius in a good spot so that it's helpful. So in this particular case, the tangent line, which is this right here, and the radius, what that key concept is telling you is that they're perpendicular. Letter B says if a line is perpendicular to an endpoint of the radius, then the line is tangent. So it's basically giving this to you two ways. It's saying if you know that this is tangent and you know that that's the radius, then these will be 90 degrees. If you say it the other way around, if you have a 90 degrees and you have a radius, then the line must be tangent. So it's saying the exact same thing but in two different orders. So that takes care of our key concepts and our definition. So let's look at some examples. Oh, nope, we got one more key concept. The next one in the key concept, it says how many tangents can you draw to the circle from point T? And we pretty much saw this on the other screen, but the idea is that you can draw two. It says if a point lies outside the circle, two tangent lines can be drawn from the point to the circle. So if you start at T and draw a line towards the circle, and you start at T and draw a line towards the other side of a circle, and I know my drawing isn't super great here, but there's going to be a point of tangency. Both of these are going to be tangent. I'm going to call this point of tangency A and this point of tangency B. So depending on wherever you start, there's two tangent lines. The thing that I want you to jot down is that these tangent lines or these segments, so from T to A, it's the same distance as it is from T to B, because they're starting at the same point and going towards that circle. So this length and this length are the same. So those two tangent segments are congruent. So from that point out there. If we were to have another point, for instance, it would have two tangents to the circle. Oh, and that's drawing terribly, I'm sorry. And those would be the same, and those would be the same. So from any point outside the circle, there are two tangent lines, and those two tangent segments are congruent. So now let's look at some examples. It says find the value of x if DE, line segment DE, is tangent to the circle. So what I'm telling you is that DE is a tangent segment, tangent line, but notice it's touching the circle in one place. The other thing, this is labeled O, and you see that from D to O is going through the center, so that means that this is the radius. The key concept in box labeled A and B said that if a line is tangent to the circle, then the line is perpendicular to the radius. So that means this is 90 degrees. What we have here is a triangle with a 90-degree angle. Triangles add up to 180 degrees, so that 90 degrees added to that 38 added to the x is going to end up equaling 180. And most of you just type it in your calculator 180 and end up subtracting, but x equals 52. Number 4, it says it's asking, is line segment AB tangent to C? So this is now going the other way. It's asking you to check this right here. It's saying if these things are perpendicular, then it will be tangent. So it looks like it could be 90 degrees. So it's saying, is it tangent? I'm going to draw this in here and check it, because if this is a right triangle, we know that in a right triangle, a squared plus b squared equals c squared. So if this is true, and this indeed is a 90 degrees, and this is the tangent, then this relationship is going to hold. So 8 squared plus 12 squared is going to equal 17 squared. So let's go ahead and check this. 8 squared is 64, 12 squared is 144, add them together, so this is 208. When I do 17 squared, it's 289. No, these two things are not congruent, so this means that this is not a 90-degree angle, so that means that this line segment right here is not actually tangent. It was drawn to look like it was, but it isn't actually tangent. All right, in the next one, it says, what is the perimeter of the triangle? Well, if you notice, we have a point out here. This is a circumscribed angle. We're not really dealing with that though, but the idea is that because it's a point outside and it's going towards the circle, this is a point of tangency and a point of tangency. So these are tangent lines. Looking back at key concept C, it said if a point lies outside the circle, two tangent lines can be drawn. What we also discussed is that the length from this point outside the circle to the point of tangency and its other are congruent. So if we have here is 6 inches, that means this length over here is 6 inches. If the entire left side of the triangle is 9 inches and part of it is 6, that must be 3. Here's yet another point outside the circle, and as it goes towards the circle and hits at its point of tangency, we have also two congruent segments. If one of them's 3, the other's 3, and we can kind of work our way around. So now we have a line segment, or the side of the triangle, that's 8 inches, where part of it's 3, so that must be 5, so they add up. Here's another point outside the circle, and as it approaches the circle to that point of tangency, it's only touching in one spot, we're getting segments that are congruent. We had to go all the way around the circle because we needed to find what this amount was, because when it deals with perimeter, perimeter is all those sides added up. Well, one side it told us was 9, one side it told us was 8, so that means this side length right here is 6 and 5, which is 11. So 8 and 9 and 11 is equal to 28 inches in perimeter. Couple more. It says, okay, you try. So find the value of x. Couple of things here. This is that idea of that circumscribed, angle. And the circumscribed angle is 180 degrees minus the central angle. I don't think that's going to be helpful here because we don't know what the central angle is, but look what else we have. We have a line that's tangent to the circle, and we have a radius. And we know that the radius and the tangent form a 90 degrees. I have another radius and another tangent line, and that's 90 degrees. So ultimately what I have here is this isn't necessarily going to help us, but I have a four-sided figure. It's a kite, but whatever. That's 360 degrees total. So 360 degrees minus 60 minus 90 minus 90 is going to give me that x equals 120. So again, just showing you this idea is that the circumscribed angle is 180 degrees minus the central angle. Well, yeah, the 60 equals 180 degrees minus that 120. So it does hold. Letter B, find the perimeter of QX. Find QX if the perimeter is 88. So here, very similar to the problem we did on the previous page, they're telling us what the perimeter is, and we're needing to then find where's QX, right here. So if P is going towards the circle and it's creating PX is 15, then PZ is 15. Looking at point R, going towards Z is 17, so going towards Y is 17. So if we have 88, and we know that I have 30 centimeters from here, and I have 34 centimeters from here, these two distances are going to be the same thing. So we can end up subtracting and then splitting the difference. So when I subtracted, I ended up getting 24, which means this must be 12 and this must be 12. The other way to do it would be kind of thinking about setting up an equation. We could say that the 15 plus the 15 plus the 17 plus the 17 plus those two unknown x's have to add up to 88. Either way, you're doing the exact same thing. We're finding those unknown chunks. All right, one more problem. Number 7, it says PA and PB are tangent to the circle. So we have the point here, P, so PA and PB, so that must also be 21. It says find the value of x. I mentioned that this is a circumscribed angle, so its measure is 180 degrees minus the central angle. So 180 degrees minus 92.8 ends up being, this x here is 87.2. Your other way around it is if that's a tangent and a radius, I have 90. A tangent and a radius is 90. So 360 minus 90 minus 92.8 minus 90 is going to give you that 97.2. It says find the perimeter. Well, I already filled in the 21 over here because of those idea of tangents. This is a radius, and the radii are congruent because they're going to the circle. So add up your 20, your 20, your 21, and your 21, and you get 82 centimeters. And then lastly, it says find the value of PC. So to find PC, what I did was I redrew my triangle, but P to C is the diagonal across, and what it does is it creates a right triangle. So I saw Pythagorean theorem where you take a squared plus b squared equals c squared. So I plugged in all my numbers, 20 squared plus 21 squared was that PC that I was trying to find. Added everything up to undo a square, I square root, so PC ended up being 29 centimeters. So I know that was quick. Do the best you can. Let me know what questions you have, and we'll go from there. Thank you so much.